To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So my dear children, in the earlier chapter we discussed several things regarding the biosphere lesson, and also we identify the structural components that can be observed within the biosphere. And also, my dear children, after that we discussed about the growth curves, right, and the several stages that can be identified within the growth curve. Now within this lesson part, first of all we are going to discuss about the growth curve of human population. Growth curve of human population, right. So although the growth curve of a natural population is S-shaped, you can remember that the normal population growth curve is having like an S shape, okay. However, it takes J shape for the human population. For the human population, the shape is like J, as you can see within the figure, right. It is still in the second phase, which is the exponential phase, okay. So that means the human population is still in the exponential phase. So our human population is still in the second phase, my dear children. That means our human population still keep getting growing, okay. This is still keep getting growing, right. So that's why it is we can say that our human growth curve is still in the second phase. So my dear children, as you can see, this is the growth curve of the human population. So we have passed the lag phase. Now we have entered to the second, which is the exponential phase. Okay, then it has taken 300,000 years for the human population to become 1 billion. But it has taken only 130 years for it to become 2 billions and 15 years for it to become 4 billion. So my dear children, the population growth is given within the first point over here. See, it has taken 300,000 years for the human population to become 1 billion. To become 1 billion, human population took 300,000 years, right? 300,000 years to become 1 billion, okay? To become 1 billion, 300,000 years. So very much longer time to become 1 billion. Then let's see what has happened. But it has taken only 130 years for it to become 2 billions. Then after that, to become 2 billion, it took only 130 years, okay. From 300,000 years to become twice as that, it took only 130 years, okay. Then, and 15 years it to become 4 billion. Then after that, my dear children, only 15 years to become 2 billion. See, from 1 billion to 2 billion, exactly 2 times, okay. Just took only 15 years. So there is a dramatical decrease in the number of years taken to double it. So for the first billion, 300,000 years. For the next one, just 130. Then for the next one, only 15 years. See, only 15 years. So there are 2 reasons for this rapid growth. So there is 2 reasons, right? There are 2 main reasons for this rapid growth. So you know that in order to grow heavily like this, definitely the number of births should increase, okay. And also there should be another one. The deaths also should decrease. The death toll should be also increase. Death toll also decrease. While decreasing the death toll, right, what will happen? What should happen is the births also should increase. increase in births, decrease in deaths. In that way, the population is keep getting increasing. Okay, so there are two reasons for this rapid growth. Number one, increasing births. Increasing births, right? Increase of the births. People who are born to the world is keep getting increased from time to time. Then decreasing deaths. Decreasing deaths. So number one is increase in births. Number two is decrease in deaths. These are the two main, right? Two main reasons for the rapid development of the growth. Okay. Then the next point given, the development of technology, progress in the medical field, and high rate of food production are some of the reasons for high population growth. So rather than these two main cases, there can be other cases as well like this. What are those? Development of the technology, the technological advancement, development. Because of the technological advancement or the technological development, what will happen? You know that now, because of the predation, because of the parasitism, because of certain diseases, you know that people is going to die. But however, with the development of the technology, with the development of new medicine, right, and medical technologies, what will happen, my dear children? You can definitely, right, you know that definitely the medication, when the medications are going to improve, then the number of people who are going to die because of those reasons are also going to reduce. So these advanced technologies is also helping for the growth of population in very much larger extent. Okay. So here it is given, the development of the technology, progress in the medical field, and high rate of food production are some of the reasons for high population. So other than the development of technology, progress in the medical field, this is also related to the technological development, my dear children. Okay, like I said earlier, development of new medicines and development of new technologies, new machines, right? So this will definitely reduce the diseases and parasitism and also other kinds of issues created with the health problems. Okay, then other than that, high rate of food production. So with the technological advancement, you know that nowadays scientists have prepared several kinds of agricultural crops that can give out more harvest within less time period. And also, my dear children, with the increase of the number of people, large land areas are being harvested from time to time. So high growth in food also can be observed within our environment. And for this process, technological development was a very quite factor. Okay, then here it is given. So these things are some reasons other than the main two. These are the other reasons that will provide or that will give out high population growth. Right then. So growth curve of human population has given, my dear children, within this graph. As you can see here, starting from 250 million, that means first AD, starting from there, right, there within the first AD, there was only 250 million people, right? So over from there, right, the number has got increased from billions like this. So when it comes to from 1 AD to 200, so there was very slow growth, then 400, 600, 800, from 1000, 2000, 1400, 1200, 1400, 1600, then after 1800, my dear children, after 1800 AD, okay, and after 1800 AD, then our population reached 1 billion. That was the turning point, my dear children, right? So this is the, as you can see, this is the lag phase. This is the lag phase. You can clearly identify the population growth is very slow, lag phase. So as you can see, when moving from here to, from 1 AD to 1800 AD, the growth was very slow, right? Actually, as you can see here, starting from this column to, from this height to reach the top margin of the first billion, it took around how much years? 1 to 1800, almost about 1800 years. Okay. After that, my dear children, then we can observe the rapid increase of the growth. See, so from here to here 2 billion, here to here 3 billion, then 4 billion, 5 billion, 6 billion, 7 billion. Check the year difference. So here to here, it took like 1800 years to become 1 billion. Then after that, like about here, see, 100 years, then about 125 years, right? 125, about 125 years. Then from here to here, like about one after from 125 years to 1 billion to become 2 billion, then 2 to become 3, like about how much of years? Like about 30 years, right? About 30 years. Then from here to here, like about how much? Then from here to here, like about 15 years, right? Like about 15 years. Then here to here, from 17.4 to 87, that means like around 84, the plus 3, 87, that's around 13 years, from 4 to 5 billion. Then here, like around 12. So as you can see here, gradually the time period is getting decreased to increase 1 billion of people. When increasing 1 billion of people, gradually the time is getting decreased, right? There is a gradual decrease in the time period. Actually, not gradual, it is dramatical. Dramatical is the correct word, right? There's a heavy change, heavy decrease in the number of years, right? So as you can see now, we have, after 1800 AD, we have entered the exponential phase. So the rapid growth, right, can be observed without any trouble within the second phase, as you can see, right? So still the human population is keep getting increased from time to time, my dear children. So we are still in the exponential phase. So this is the growth phase, or the second growth phase of the human population. So here to here the first phase, and here to here the second phase. So we are still in the second phase. So our human population is still in the second phase, which is the exponential phase, right? Now here we are, we can observe rapid growth in the population, right? Then, my dear children, in the near future, the human population will reach to the third or the decelerating phase, right? So the high growth rate of the human population mainly can be observed because of decreasing deaths and increase in births. Other than that, the advanced technological development in the medication field and in the medical field, and also in other agricultural and food production areas, those things are also has a direct impact between the population increase. Okay, right? So let's move on to see the next one. Yes, so you are given with the you are given with an assignment. According to the graph, predict the time that would take for the world human population to become twice as it was in 2013. So let's see the graph. 2013, 7 billion. Okay, let's see from here to here, now you can see that from 1 to 7 billion the time period is given, 1 billion to 2 billion. Now let's subtract and see 1804, here 2013. So from here to here, like 7 billion, right? So let's subtract and see how much is the answer. So 2013, you subtract 1804. So here 9. Then you take one to the other side. then it becomes 0, then here 1. So it's around, my dear children, 109 years. So it took around 109 years to reach from 1 billion to 7 billion, right? From 1 billion to 7 billion, 109 years. Let's take roughly as 110 years. Okay, so 110 years. So from here to 1 billion, 110 years. Then what will happen to become it more than that? I mean, like now we are discussing it to become twice, no? That means 7 billion times 2, 14 billion. How long will it take? Definitely less than this years, right? Definitely less than this much. Definitely less than half. Like will take around 50 years, right? Like 50 years, 50 to 30 years, 30 to 50 years, right? It will take around 30 to 50 years. So you go ahead and you can use the internet for this purpose. You go ahead and check how much is the population right now at the at our planet Earth, right? Recently it reached another milestone, right? You go ahead and check. Recently, like 2 or 3 months back, it reached another milestone, right? There was a certain number achieved by the human population. So you go ahead and check that. Within the internet you can observe it. Even there are several there are certain different kinds of calculators to count out the total population in the planet Earth. Now this is not accurate, but however there are certain types of calculators, my dear children, not 100% accurate, but up to a certain level those statistics are true. So you go ahead and check. Those things are available in the internet to check, my dear children. So as for my prediction, I'm just I'll think that, as for my prediction, I predict that it will take around 30 to 50 years to become 14 billion. Okay, right then. So let's head on to see the next one. So now we are going to discuss a fresh new topic, my dear children. Here we are going to discuss about mechanisms involved in maintaining the equilibrium. Mechanisms involved in maintaining the equilibrium. Under that given a subtopic, flow of energy and nutrients. So here mainly we are going to discuss, my dear children, mechanisms or processes that involve in maintaining the equilibrium. To maintain the equilibrium, right, in our biosphere or in our ecosystems, right? What are the mechanisms or what are the processes which is going to help us? Okay, not actually us, but for the environment or for the ecosystem. What are the special kinds of mechanisms that can help, right? So here it is given, the energy source of all ecosystems in the biosphere is the sun. We know already that thing, right? Starting from grade 6 onwards, my dear children, will be starting about our sun. So we know that sun is the main energy source in planet Earth, right? Within our planet Earth, sun is the main source of energy. Without sun, we won't be able to live, because you know that plants are going to do the process of photosynthesis by using the sunlight. And also, sunlight is the main energy source that contained in each and every bodies of organisms. Why I'm telling that? Because, my dear children, you know that each and every organism who is living in planet Earth mainly dependent on plant, directly or indirectly, or else these things are also called as autotrophic organisms. So we depend on autotrophic organisms which do the photosynthesis process. So energy for the photosynthesis process is obtained from solar energy or from sunlight. So the main energy contained in our tissues and bones and all the other things, all the other living tissues, is mainly composed of sun or solar energy, right? Okay then. Flow of energy and nutrients among ecosystem is essential for the existence of the biosphere. So you know that plants are the ones who are acting as the producers. They are the ones who is going to produce the food for us. So plants or the autotrophic organisms, like other than that plants, you know that there are algae as well which can do the photosynthesis. So algae and plants, those are the two main autotrophic organisms in our environment. Those are the two main autotrophic organisms. So these autotrophic organisms are going to produce the new food items, right? So these food items are being consumed by us, right? These food items are being consumed by us. For a simple example, a grass plant, then rabbit is going to eat that. Then we capture rabbit and we eat. Or else when you take a lion, okay, so grass, then grass is being eaten by the rabbit, then rabbit is being eaten by the lion. So ultimately, lion has the energy which is obtained from the plant. Plant produces the energy from sunlight. So flow of energy from one particular organism to another should be there in order to observe, right? In order to observe the equilibrium in a certain environment. So to maintain the environment, the flow of energy and nutrients from one certain body to another is very important. Okay, right. Then my dear children, under that you are given with another subtopic. So this is the food web. The mutual relationship for food among organisms is referred to as food webs. The mutual relationships, that means different kinds of types of relationship that can be observed from one organism to another. I mean, they are interacting each other in order to achieve their nutrient requirements. Okay, in order to satisfy their nutrition requirement, one particular organism is going to depend or consume, right, another kind of organism, right? So here, my dear children, mainly from one particular organism to another, the energy and also nutrients are being passed, right? So my dear children, here the specialty is, now I told you that these food webs are going to show the transfer of energy from one particular organism to another. But there is a special thing. Different trophic levels of many food chains are interconnected in a web-like structure in the biosphere. Here the other specialty is that the organisms or these links in a food chain are interconnected in several ways. These things are interconnected in several ways in order to create the food webs, my dear children. So a simple food chain shows the flow of energy starting from a producer like a plant, then plant to grasshopper. Okay, grass is a plant, then that plant to grasshopper. From grasshopper to small rat, then rat, from rat to a rabbit. No, rabbit, we can't take rabbit, right? From rat to a cat. Okay, from cat to an eagle, and so on. Okay, so this is a simple, that it is a linear path from one particular organism, autotrophic organism, right, to a consumer, from one particular organism to another. This is just a one single flow. When these flows, several flows are interconnected each other, in that case, my dear children, we can observe a food web. It is a web-like structure, not a linear path. Okay, so here it is given, due to this relationship, an organism is free to depend on different types of food. This helps to avoid the bioaccumulation of organisms. So because of organisms can depend on different kinds of food, especially heterotrophic organisms, under that omnivore organisms. If you take omnivore organisms, they can depend on like several food items. If you take human beings have the ability to eat any kind of a junk, right? So they have the ability to eat any kind of a junk. I mean, like, junk means any kind of a food, Okay, it can be a plant material, animal material, anything, right? Especially they can eat flesh or plants, both, without any trouble. So therefore, my dear children, we have different tastes. So bioaccumulation is getting reduced because of that. That means number of organisms, right? Number of organisms living in a certain environment is going to reduce from time to time. Okay, from time to time this is going to reduce. It's mainly because now, because of the organisms, they are going to catch these organisms. They're going to catch their prey as their prey. So because of that thing, my dear children, what will happen? The bioaccumulation, or the number of organisms who are living, is going to decrease. If a certain species is somewhat hard to catch, then they can depend on others. Okay, then they can depend on others, as there are plenty of examples, or as there are plenty of kinds of species living in the environment. Okay, so when these things join together, when these several food chains join together, right, we can observe a food web. So let's see the next content then. So as you can see, food web diagram of food web is given here, my dear children. See, so there are different organisms. There are different organisms over here. You can observe one particular food web, and over here also you can observe another one, right? So here, starting from corn to grasshopper to rat to python to an eagle. See, so this is one way around. This is a one-way path. This is called as a food chain. So starting from another one, I'm going to show you another one, starting from corn to grasshopper to rat to the eagle. Another one. See, then there are two different food chains from here to here. Corn, grasshopper, rat, then the eagle. Corn, rat, python, and the eagle. See, these things are the ones which are referred as, right, food chains, my dear children. One single pathway, right, which the energy is going to transmit, is called a food chain. This is a food chain. So in here also you can observe another food chain, a flowering plant, or else a lavender plant. Butterfly is being eaten by frog, then frog is getting eaten by a python, then python is getting eaten by an eagle. Okay, so like that. So there are different kinds of relationship among these organisms. So each of these, as you can see, there is a specialty, my dear children. In order to start each and every food web, there should be a plant or else a producer. So if there are no any producers, that means, my dear children, the starting position of each and every food web or else a food chain is from a plant or else a producer. Producers, without the producers, we won't be able to create food webs or food chains, because these are the ones in our environment which behaves to produce the food. That's why they are referred to as producers. Now, if you take the one which is over here, mangoes, being eaten by fruit fly, being eaten by dragonfly, being eaten by the frog, being eaten by the python, being eaten by the eagle. See how the energy is being transmitted. There are several links. These things are referred to as links, my dear children. Each individual contained within the food chain is referred to as links, right? So there are different links, 1, 2, 3, 4, 5. There are 6 links. Okay, so like this way, my dear children, a web-like structure which is created by the collection of large number of food chains together is referred to as, right, a food web. This is the one which is referred to as a food web. And the other specialty is that if you take food webs, all of the food webs or else chains for the both, right, all of these food chains and food webs, they are going to start, these things are going to start from a certain producer. I mean, there should be a plant or else any other kind of a producer in order to start or in order to prepare a food web or else a food chain, because producers are the ones who are behaving as producers to produce food. Without that, right, there won't be any food chains or food webs. Right then, so you are given with an assignment, build up a food web in a pond ecosystem, right? So I'm going to build up this thing then. So you have to build up a food web in pond ecosystem. So who are the organisms that can observe within a pond? We can observe frog, dragonfly, then my dear children, we can observe fish, then kingfisher or else birds, we'll mention as birds. Kingfisher and magpie both can be observed, no, birds. Right, so there are like 1, 2, 3, 4, 5 organisms. So let's make a food web then. So starting from hydrilla plant. Hydrilla plant is being eaten by frog. And you know that hydrilla plant is being eaten by, again, fish. Then my dear children, fish is being eaten by frog. Then dragonfly. So dragonfly is being eaten by frog once again. Then you know that there are different kinds of mosquito larvae living in pond water, right? So larva. So hydrilla plants are being consumed by larva. Larva is being eaten by the dragonfly. Then dragonfly is being eaten by the frog. Then my dear children, I'll take the birds. So over here, you can observe birds. So different kinds of birds consume fish. Then once again, who are the others? 1, 2, 3, 4, 5, 6. Okay, there are 6 organisms. Now we have to interconnect the other lines. So there are birds which is going to feed on frog as well. So this is also another line. And there are some special birds which even can feed on dragonflies and also on larva too. Right. So my dear children, this is a simple food web that we can observe in pond ecosystem. So this is the hydrilla plant. As you can see here, all the point heads are directed towards other organisms, while like the arrowheads are pointed towards the other organisms, while the other end of the arrowhead is starting from the hydrilla plant. See, all the other ends are starting from the hydrilla plant. So this is called as a food web. Okay, so I took only 6 organisms over here within a pond environment. There is larva, then frog, dragonfly, fish and birds, so and hydrilla plant. So hydrilla plant is acting as the producer, being eaten by the frog, right? Then hydrilla plant is being eaten by the fish. Then fish is being eaten by the frog. Then my dear children, frog is being eaten by different kinds of birds. Then over here you can observe hydrilla plant is being eaten by larva. Then larva is being eaten by dragonfly, right? Then my dear children, dragonfly is being eaten by some kind of birds, right? Like that we can observe different kinds of relationships over here. So this is called as the food web, my dear children, the food web. So there are different links within the food web, and also my dear children, food web is created by collection of different number of food chains. Okay then. Right, then the next topic, my dear children, the food chains. Now already you know what do you mean by a food chain, right? So food chain is it is a one certain pathway of transferring energy or else nutrients from one organism to another. Here, my dear children, now when you take the food web, one single pathway of a food web is referred as a food chain. One single pathway of a food web is referred as a food chain. So here the sequence of energy and materials flow from producer to consumers, such as primary consumer and then to the secondary consumer, is referred to as a food chain. So this can be shown in a linear diagram as follows. So my dear children, can you remember we discussed about the food webs? So this is a food chain. So food web, when you take a food web and a food chain are two different things. Even though food webs contain different kinds of food chains, food chain only show how the energy is being transferred from one particular organism to another, from producer to consumers. Okay, by the collection of large number of food chains, a food web is created. So here this is going to show the sequence of energy and material flow from producer to consumer, such as the primary consumer. This is the primary consumer, the first and foremost consumer. Then the secondary consumer. This is the secondary consumer. This is the producer. Producer, primary consumer, secondary consumer, tertiary consumer, then quaternary or any other, then fourth level consumers. Alright. Okay. Right. So I hope that you got the idea. What do you mean by this? Food chains. So here in a food chain, my dear children, this is going to show only one single pathway like this. Right then. So a food chain is given with several figures, my dear children, over here. So an example for a food chain, starting from producer, which is the grass, the primary consumer, the first and foremost consumer. Most commonly it's going to be a herbivore, right? So grasshopper. Then grasshopper is being eaten by the secondary consumer, rat. Then the tertiary consumer. Then quaternary consumer, right? Quaternary consumer, which is the hawk, the fourth one. So 1, 2, 3, 4, 5. There are 5 links. This is the producer and there are 4 consumers. 1, 2, 3, 4. Okay. So food chain is going to show how the energy and the nutrients, materials is being passed from the producer to primary, secondary, tertiary and other levels of consumers. Okay. Right then. So you are given with an assignment once more. Observe different modes of nutrition consumed by different organisms in the environment. Write down their relationships for food. Okay, so within our environment, you know that there are different kinds of organisms. Mainly there are producers or autotrophic organisms which is going to produce food. So they use photosynthesis, or sometimes like bacteria, they use chemoautotrophism to produce energy. Chemoautotrophism means, my dear children, they use chemical energy, right? By using a certain chemical reaction, they get energy as chemical energy. Okay, so my dear children, in here it is given, you have to observe different modes of nutrition consumed by different organisms in the environment. So different organisms in our environment use different kinds of nutrition patterns. So you have to observe these things, right? You have to observe these things. Then you have to write down their relationship for food. Then you have to write down their relationship for the food. Okay, So I'll give you 3 examples, my dear children, right? 3 types of organisms with 3 different food mode of nutrition and their food types. Okay, relationship for food. Right, then we can start with a normal human being. So human, right? Human being. So you know that humans are heterotrophic and mostly humans are omnivore organisms. Omnivore organisms, right? And we are going to depend, or humans are depending on plants and flesh of other organisms. Then number 2, lion, carnivore. So lion is going to depend on specially on flesh of the other animals, right? So lion depend on flesh of other animals. So we'll write some examples for the food which they consume. Rice, okay, then fruits, then goats, hens, eggs, cows, pigs. Then we'll write down for a lion what are the food types. So they depend on goats, rabbits, deer, then my dear children, they depend on other types of cows. Then number 3, I'll use goat, herbivore. Herbivore organism. So you know that herbivore organism is going to depend mainly on plants, right? So they depend mainly on plants. Examples: grass, jack, right? Then flower plants and so on. Right, I'll write another different one, my dear children. Let's take fungi and bacteria. Fungi and bacteria. What about these guys? Most of the fungi and bacteria, right, they depend on dead bodies. okay, they depend on dead bodies. Especially they are dependent on dead plant and animal bodies, my dear children. That's why the dead plant and animal materials are getting decomposed because of the action of these guys, right? So we can write as decomposers. Decomposers. These guys are the ones who are acting as decomposers. Main function is to digest and decompose all the dead plant and animal materials in our environment. Fungi is a main one who helps in that process. So examples: decomposing dead animals and plants as they consume these dead structures. Right. So these are several kinds of organisms who are living in our environment. And my dear children, their relationship for food. First of all, human, omnivore organism. They depend on plants and flesh of other animals. For an example, rice, fruits, goats, hens, eggs, cows and pigs. So there is a vast variety of food items. Then next one, my dear children, lion, a carnivore organism. So they depend on flesh of the other animals. Examples given: goats, rabbits, deers and cows. Right? Then my dear children, goat. Goat is a herbivore organism. Goat is a herbivore organism, depend mainly on plants, okay, like grass, jack plants, flower plants and so on, okay. Then my dear children, I have written down a special one over here as the fourth one, right? Fungi and bacteria. These guys are also called as decomposers. Decomposers, because those are the ones which helps to decompose food items, not only food items but also dead bodies of the organisms. So these organisms help in decomposing, right? Decomposing or for the decomposition process of dead bodies. So example given: decomposing dead animals and plants as they consume these dead structures. So these guys are called as decomposers because they are decomposing dead animals and plants as they consume these dead structures. Okay, right. So these are, right, these are, my dear children, these are the ones which we can observe in our environment as our main types of organisms and also the types of foods that they use, right? So now let's head on to see the other content. Now given with another subtopic, trophic level. Let's see. Every organism belongs to a certain trophic level according to their mode of nutrition. The links of a food chain are known as trophic levels. So can you remember I told you about the food chains? So link of a food chain. So like I said, when we are discussing about the food chains, I told you that there are several links in food chains. So when you take a food chain, my dear children, a certain link is referred as a trophic level. One certain link of a food chain is referred as a trophic level. So every organism belongs to a certain trophic level according to their mode of nutrition. So according to the mode of nutrition, right, they belong to a certain trophic level. The links of food chain are known as trophic levels. So like I said, the links of the food chain are known to as trophic levels. Then The number of trophic levels of a food chain cannot be exactly predicted. So, number of levels in the food chain, we won't be able to exactly predict how much is it. Okay, we won't be able to predict the number of links or number of trophic levels in a food chain. Okay, it's because that, my dear children, this can be changed according to the organisms, according to the number of organisms, right? According to the types of organisms, this can change. We won't be able to exactly predict how much of trophic levels are there in a certain food chain. Okay, most often it is less than 5 links, but however it is given there, it is given here, more often it is less than 5 links. Somehow the organisms belong to last trophic level would be carnivorous predators. So however, my dear children, the last organism can be a carnivorous predator. Okay, it can be a carnivorous predator. Usually that's how these food chains work, right? When you go to the end of the food chain, okay, the last organism or the last trophic level most probably should be a carnivore, right? It should be a carnivore predator, or else it can be omnivore. Okay, it can be omnivore too. Right, then all organisms can be divided into 3 groups on the basis of their mode of nutrition. So all organisms in the planet Earth can be divided into 3 main categories according to their mode of nutrition. Okay, so let's see. You know that there are certain types of organisms which can produce food. So these are called as autotrophic organisms. So produce food in themselves, right? Autotrophic organisms. Number 2, heterotrophic. So heterotrophic organisms, they depend on food produced by autotrophic organisms, right? So depend on food produced by autotrophics. The next one, third one, decomposers. Consume and decompose right? Consume and decompose dead plant and animals. So consume and decompose dead plant and animals. Okay, this is the third one, decomposers. So autotrophic organisms produce food in themselves. Heterotrophic organisms depend on food produced by autotrophics. Then third one, decomposers consume and decompose dead plant and animals. This is the right So these are the three main organisms, three main categories of organisms that we can identify within our biosphere, my dear children. Okay. So humans, we belong to the heterotrophic zone. Bacteria and fungi, they belong to the decomposers. Then plants and algae, they belong to the autotrophic organisms, and some bacteria as well. Okay, so there are some bacteria as well which can do the autotrophism. Okay, right. So these are the three main types of organisms according to basis of their mode of nutrition. Right then, first of all, then we are going to discuss about autotrophs, autotrophic organisms. Let's see. Organisms such as green plants, algae, which can transform simple inorganic compounds into organic compounds to fulfill their nutrition requirement, are called as autotrophs. So autotrophic organisms are the organisms, my dear children, which can convert simple inorganic substances into complex organic substances. This is the one which is referred as photosynthesis, right? So in simple photosynthesis, right? So here they use inorganic substances like water and carbon dioxide, and my dear children, by using those and also by using the solar energy, they are converting these substances into create glucose, which is a complex organic compound, and some extra other substances as well like oxygen gas. So these organisms, the autotrophs, they can use simple inorganic substances to provide or to create complex organic substances as food. Okay, food. Then according to the energy source used to produce their food, autotrophs can be divided into two groups as photoautotrophs and chemoautotrophs. So we have studied these things when we are discussing about the lessons related to grade 10, my dear children. Photoautotrophs and chemoautotrophs. So photoautotrophs and chemoautotrophs, my dear children. Photoautotrophic organisms means those are the organisms, right? Photoautotrophic organisms are the organisms that is going to feed or that is going to produce food by using photo. Photo means light. So in simple, these organisms are the ones who can carry out photosynthesis. So they use light energy or photo to produce their food. Okay. Then chemoautotrophs are those organisms use chemical reactions to produce their food. Chemical reaction means chemical energy. That's why it is referred as chemoautotrophs. Photoautotrophs and chemoautotrophs. So photoautotrophism, in here, photo or light energy is being used, especially the sunlight. Then chemoautotrophs, chemical energy is being used. Next one, green plants are photoautotrophs and some bacteria are chemoautotrophs. So like I said, green plants and algae, they belong to the photoautotrophism group as they use solar energy or sunlight to produce food that they need. Then my dear children, bacteria are the ones which are considered as chemoautotrophs. Some bacteria. Okay, right. These are autotrophic organisms. Then my dear children, heterotrophs. The animals that cannot produce their own food and depend on food produced by other organisms belong to this group. They are known as consumers. The consumers are further divided as follows. So heterotrophs, my dear children, right? Heterotrophs. So heterotrophs or heterotrophic organisms. Heterotrophic organisms are the organisms that is going to depend on food which is produced by the autotrophic organisms. Okay, heterotrophs are the organisms that is going to depend on food which is produced by autotrophic organisms. Autotrophic organisms are the ones who are acting as the main producers. You already know that. So these main producers are going to produce food items. So these food items are being consumed by these heterotrophic organisms. Okay. So all the animals are heterotrophic organisms. Animals includes us too. You already know that. So animals that cannot produce own food, which depend on the food produced by the other organisms, belong to the heterotrophism. So they are known as consumers. The other specialty is that these organisms are also referred to as consumers because they are the one who is going to consume food. Consumers. Then primary, there are three types of, right? There are three types of consumers, right? So consumers can be divided again to as follows. Primary consumers. Primary consumers. So primary consumers, they are the first type of consumers. So they are the ones who are going to directly depend on the producers. That means herbivore animals, right? Directly depend on the herbivore and directly depend on the plants and other types of autotrophic organisms. So can you remember we wrote down the relationship between food item and their mode of nutrition under an assignment previously. Over there we discussed about the goat. Can you remember goats are like eating most of the green plants. So therefore those kinds of organisms belong to the first group, which are the primary consumers of heterotrophic organisms, right? So probably, most probably, this is a herbivore animal and they feed on producers. The first type, primary consumers. Then the second type given, secondary consumers. Secondary consumers. So they are carnivorous or omnivorous. So these organisms are carnivorous or omnivorous. Feed on primary consumers. So these guys, they feed on primary consumers. Primary consumers feed on the previous autotrophic organisms. So as you can see, there is a flow of energy. Okay, primary consumers, right? They are going to feed on autotrophic organisms who are the ones which is going to produce the food. Then these secondary consumers are depending on primary consumers. So the energy is being transferred, right? Energy is being transported from autotrophic organism, which are plants and algae, towards the primary consumer and to the secondary consumer now. Okay. Then the third one, my dear children, the territory consumers. Territory consumers. Mostly they are carnivorous. So territory consumer means from first to second to the third level, third trophic level, third link. Okay. So most probably these organisms are carnivorous. So as you can see, now you can observe the three types of heterotrophs. Herbivore organisms which are going to feed on producers. Omnivore organisms which is going to feed on primary or consumers. It can be carnivore or omnivore. Then third one, mostly carnivorous or can be also omnivorous, right? So according to that, we can observe three types of heterotrophic organisms, carnivorous, herbivorous and omnivorous. So we discussed this thing under that assignment. Can you remember? Right then. So these are the three main heterotrophs that we can observe, my dear children. Three main types of heterotrophic organisms. All of the heterotrophic organisms are going to depend on food, right? Food which is produced by the green plants or the producers. Right then the third one, decomposers, right? Number 3, decomposers. So you know who are decomposers. So here it is given, organisms feed on bodies of dead organisms by converting complex organic compounds into simple compounds are known as decomposers. So organisms feed on bodies of dead organisms. Can you remember we wrote down this thing, right? So these are the organisms which is going to depend on dead bodies of the organisms. They consume dead bodies, right? And they decompose these things. So within the dead bodies, you know that each and every dead body means these things are nutrition. Nutrition means actually these things are made by carbon, hydrogen, oxygen and nitrogen, and also there are like several other elements, and these elemental composition would create, you know, like biomolecules, carbohydrate, protein, lipids, and also nucleic acid. So these things are like nutrition, a heaven of nutrition for the decomposers, especially for the fungi and bacteria and other types of microorganisms. So what they're going to do is, when a certain animal or else an organism is going to die, they're going to come and feed on this whole body, right? So upon consumption, the entire body of the organism, dead organism, is going to decompose gradually as their components are being now utilized by the microorganisms. So organisms feed on bodies of dead organisms by converting complex organic compounds into simple compounds are known as decomposers. The other thing then, my dear children, you know that our bodies are mainly made up of those biomolecules which I have mentioned earlier, like carbohydrates, proteins, lipids, nucleic acids, and so on. So those things are very heavy and very complex organic materials. So when these organisms, decomposers, when they are going to consume these biomolecules or complex organic molecules, what will happen? They are converting these biomolecules into very simpler compounds like carbon dioxide gas. Okay, once again, as you know that carbon dioxide gas is inorganic. So they're using these main biological molecules and they are converting these biological molecules into simpler compounds within the environment by the decomposers. So when consuming dead bodies, these organisms, these microorganisms, they also help to convert these, right, bodies, the biological molecules or the special structures contained in their body, they convert these things into carbon dioxide gas like structures, which are very simple. Okay, so that is a specialty that can be observed in decomposers. They are converting, right, they are going to convert complex molecules into simpler substances. Right then, saprophytes like bacteria and fungi belong to this group. So these organisms are also called as saprophytes. Saprophytic organisms, saprophytes. So saprophytes like bacteria and fungi belong to this group. So like I said, saprophytes like bacteria and fungi, those are the good examples for the decomposers. Even we wrote down the examples under the previous assignment, my dear children. I hope that you could remember those things. So saprophytes like bacteria and fungi belong to this group. This process is called the decomposition. So this process is referred to as the decomposition. So as you can see here within the figure, there is a dead animal and the stages of decomposition process of a dead animal body is given in the figure. So this decomposition process is mainly carried out by microorganisms, my dear children, especially bacteria and fungi. So these bacteria and fungi, therefore referred to as decomposers. So what they are going to do is they are going to use the complex structures, complex biomolecules contained within the living body, within the dead bodies, and they are going to feed on these complex molecules, right? And as a byproduct, they are releasing several gases to the environment, right? So these things are simple. So these decomposers, what they are going to do mainly is they are going to consume those heavy structures, large molecules, and they convert into simpler substances once more, right? So you can observe the several changes in the body, right? So this is how a body is being decomposed, dead body is being decomposed. This is mainly carried out by the decomposers, which are fungi and bacteria, right? Okay, my dear children. So with that part, we have finished the second chapter. So within this second chapter, we mainly discussed about the growth curve related to the human population. And we discussed about the food chains, right? And the food webs, which involves how to show the energy flow from one particular organism to another in our environment or in our ecosystem. So we discussed all of those things. Then we discussed, my dear children, right, the types of organisms according to their mode of nutrition. We divided organisms into three main categories as autotrophic organisms, heterotrophic organisms, and as well as decomposers. Right? So autotrophic organisms are the organisms that can produce their own food. Okay, especially there are two types of organisms under the autotrophism. Those organisms are chemoautotrophs and photoautotrophs. Chemoautotrophs are bacteria-like organisms. They can produce their own food by using chemical reactions. Then, my dear children, the other type is photoautotrophic organisms. These organisms are going to use sunlight or solar energy to do photosynthesis, right? So, my dear children, after that we studied about the heterotrophic organisms. These organisms are the ones who is going to depend on autotrophic organisms. So, there are three types of heterotrophic organisms: primary, secondary, and tertiary consumers. So, usually a primary consumer, a herbivore. Secondary consumer can be a carnivore or omnivore. Third one also can be a carnivore or omnivore. Most probably it is going to be a carnivore organism. Then, my dear children, we discuss finally about the decomposers. Decomposers are the ones or the organisms that is going to help to decay down living plant and animal materials. Actually, after they are going to die, they are going to help in decomposing these things. Okay, so dead plant and animal materials are being mainly decomposed by the decomposers, right? So examples for decomposers are bacteria and fungi. Okay, decomposers, they are going to convert the complex biomolecules in living organisms into simpler compounds, right? So those are the things which we have learned within this chapter, right? So we'll be discussing even more things related to the biosphere lesson in our next chapter. In our next chapter, we'll be mainly focusing about types of ecological pyramids and their special features, right? So my dear children, I'll meet you with the third chapter to discuss those things.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.